So it's my pleasure to introduce Mr. J. Seegert.
Well, good morning. I'm also going to hand something out. If you could just take these and divide them up, pass them back. I'll tell you what they are in a second here. But it's an honor for me to be back here this year with this presentation. You've probably heard about getting rid of the middleman. We talk about that sometimes to save costs. Well, in this case, with the whole creation-evolution debate and apologetics, if we get rid of the middlemen, I'll be out of a job, because that's really who I am. The only reason that I can be here this morning is because of people like Dr. Jerry Bergman, Dr. Kevin Anderson, who are doing the real research, high-level research, technical stuff, and then I get to kind of sit at their feet and glean these things and then put it into a format that everyone else can understand very easily. So that's just kind of where God has me. I've been speaking for about 28 years, full-time for the past 7 years. And the talk that I'm giving, I actually gave in a concurrent session last year, but probably very few of you heard it, so I'm going to be presenting it this morning, and I think you're going to be very encouraged by it. It's a really neat talk. It's a fun talk, and it's going to be talking about some cutting-edge information about DNA that will just probably make your head spin as far as how exciting it actually is. And hoping to get through this fast enough, we can do a little bit of Q&A with whatever time we might have left, so we think of the questions that you might have. But I'll also give you my background in a nutshell. I was raised in a Christian home, and you can see very clearly that that is truly a Christian home there. And believe the Bible from cover to cover. Went to public school, though, all the way through high school. I'm actually a local person here. I live about less than an hour from here in Waukesha. And then when I graduated from high school, I went to a Christian college, John Brown University, to study mechanical engineering. That was Arkansas. Partway through, I became more interested in physics. But John Brown didn't have a physics major, just a minor, so I had to leave there. I came back to Wisconsin and went to the University of Wisconsin in Whitewater to get a degree in physics. And that's when my world changed quite a bit, going from a small Christian college where my engineering professors actually opened up every class in prayer to a large state university where my physics professors did not open up in prayer. They were all evolutionists. Some of them were atheists, and they were telling me in essence that everything I believed was wrong. And that really shook me to be surrounded by these PhD scientists who I assumed probably had a lot of evidence for what they believed. But I realized probably for the first time in my life that even though I knew what I believed, I didn't know why. And how did I know that God existed? How did I know that the Bible is the inspired Word of God? How did I know the creation account was scientifically valid? How did I know there was a flood? How did I know that Jesus rose from the dead? And on and on. So God put it on my heart at that point in my life to start looking into these things. And that was 28 years ago, so I've been speaking and researching and writing ever since, and then moved into full-time ministry about 7 years ago. And one of the most important things I learned when studying physics was this, to never trust an atom because they make up everything. Now, the reason I share that is to warn you about my sense of humor and to get you guys to beg me to stick with science and leave the humor up to the professionals. So I have a very dry sense of humor, and you'll probably see that throughout the talk here. But we're dealing with something here that's a problem. The mission and the passion behind the Creation Education Center is somewhat based on this. That recent studies have shown that 50 to 75% of students from Christian homes, very evangelical, fundamental Christian homes, are walking away from their faith before they finish college. Now, there are a number of factors behind this, but one of the biggest ones is that we have a set of beliefs without convictions. We're taught the right things, but we don't really know why. Kind of like me. I believed all the right things, but I really didn't know why. And it's very easy then going off to college, just having the set of beliefs that you were told by your pastor, your parents, or whomever, and now you have PhD professors who are telling you why those things, there's no way they can be true. Why is there all this evil in the world? And science has thoroughly disproven the creation account. There never was a flood because where did all that water come from? Where did it go? How did Noah get all the animals on the ark? And Jesus isn't the Son of God. And what about all the other religious books and errors and contradictions in the Bible, and on and on and on? And a lot of these Christian students end up walking away from their faith. Some of them weren't really saved to begin with, but it's a big time when they do depart from the Christian faith. And so that's why I travel around the country speaking, not just because I love science, but it's because it's ultimately about the gospel message. But you can't trust the gospel message if we're thinking, there are some probably problems with the Bible and Genesis and other places, but we know the gospel message, that's solid. How do you magically know the gospel message is trustworthy when you're admitting, maybe there are problems in the rest of the Bible? So that's what this whole conference is about, not just about science. It's really about the trustworthiness of Scripture from cover to cover. So getting back to this talk, I've kind of coined a new term that I thought was kind of neat. We're familiar with apologetics, the defense of the Christian faith. And in this conference, we're talking a fair amount about genetics. So I put them together, and I call it apologenetics. I think it's kind of a neat little phrase there. It's using genetics to defend the Christian faith. There are other ways of defending it as well. I talked about that a little bit in my concurrent session yesterday. But apologenetics, it popped into my head about a year or two ago, and thought that's kind of a neat phrase to talk about how genetics supports the Christian faith. Now, how many of you have ever seen Are You Smarter Than a Fifth Grader? A number of you have. Kind of a dangerous show. You might find out that maybe you're not smarter than a fifth grader. But we're going to change this up here this morning a little bit. We're going to ask, are you smarter than a PhD scientist? Well, most people would say, well, of course not. Those guys are brilliant. But I honestly believe that after you hear this particular talk this morning, you will truly be smarter than most PhD scientists when it comes to the creation-evolution debate. And here's why. Because most PhD scientists don't know anything about what you're going to hear this morning. Because most PhD scientists are not studying evolution. They're not studying the origin of the universe. They're not studying genetics. They're making rocket fuels, food preservatives, or curing diseases. They're doing great stuff, but they're not studying this. They just assume, well, there are scientists out there who've studied all this, and they've shown evolution is true, and they have faith in them, and it's good enough for them. They don't question them about that stuff, and those scientists don't question them about food preservatives or whatever they do. So the vast majority of scientists aren't studying this. It's not their background. They're smart people, and they know a lot about their area, but that's kind of how science works. You get your PhD, you're really sharp, but it's usually in somewhat of a narrow area because you can't know everything. Even the scientists who do study evolution, they're usually focused in a narrow area and don't know that much about the broad spectrum or maybe the genetics of it themselves. So you will really know more than most scientists out there when it comes to the creation-evolution controversy when we go through this talk. And just a little bit of a quick review. We don't have time for all of this, but there's a lot of background to this talk where I usually like to define evolution, talk about science in the Bible, and then the idea of God using evolution. We're just going to cover the first one very quickly because it's important that we define evolution. When I talk about evolution, and when all the speakers talk about evolution here these days, we are not simply talking about change. Evolution certainly does involve change and require change, but it's not just change. No one denies change, but you've got to be careful. If you say you don't believe in evolution, the person you're talking to is probably just thinking about change, and they're thinking you don't believe in change. And you'd have to be crazy not to believe in change, because we see change all the time. But that's not what I'm referring to by evolution, not just change. Yes, there is change in evolution, but it's got to be the right kind of change, and we don't see those types of change in real science. I'm also not referring to different types of dogs and horses and cats, or different types of beaks that we see on finches that Darwin got very excited about. These are facts of science. We see them all the time, but they have nothing to do with evolution, as is taught in the public school systems and the state universities. This is what I'm referring to by evolution. That supposedly about 3.8 billion years ago, there was some chemicals that came together to form a living cell, and that cell changed into every other life form on this planet over millions and millions and millions of years by accident. This is what's being taught. I think this is really just a story that's told about the past, and I don't think there's any real science behind it. So when I'm talking about evolution, this is what I'm referring to. We also call it molecules to man evolution. So I suggest when you're talking to someone and you're talking about evolution, tell them you're referring to molecules forming a living cell, which then changed itself into a human being over almost 4 billion years. Make sure you're on the same page with that. So with that, the general premise of this talk is that certain things from a distance or a certain angle can look pretty good. Like this bright red BMW looks pretty great. You would envision opening the hood and seeing a beautiful engine inside. What if, when you open that hood, instead of seeing this nice engine, you saw this? The engine's missing. Now it doesn't look so good anymore. So what at first looked pretty good, upon closer inspection, doesn't look so good anymore. That's maybe why the price tag on this thing was so low. It's kind of surprising. I think this is what we see with evolution. Certain portions of the evolutionary story seem very plausible. But upon closer inspection, you realize, oh, okay, wait a minute, that doesn't work so well anymore. For example, look at an Australian lungfish and a newt. These two creatures do not look completely different. There are many similarities here. It does not take much imagination to picture those fins getting a little stronger, a little longer, to be able to kind of creep up under shore, and then it maybe could breathe better in the air, and then eventually spend more time on land and all that. Just little changes here and there over millions of years. Even Christians, and they can picture those things and say, well, maybe that did happen, maybe God used that process. I can picture that. But again, when you peek under the hood and in essence look at the DNA, what has to happen inside this thing to make those changes, you realize it's just not possible. It's not going to happen, and that's what we're going to look at. Richard Dawkins, we always talk about, one of the world's leading atheists. Here's one of his quotes, of the many that people share. You cannot be both sane and well-educated and disbelieve in evolution. The evidence is so strong that any sane, educated person has got to believe in evolution. Just saying you are crazy if you don't believe in evolution. This is what we have in the educational system. The kids grow up hearing this over and over from their teachers and professors, so they're intimidated into saying, well, sure, I believe in evolution. I'm not crazy. You can see it all around us. There's so much evidence that all the scientists believe in it. So it's more of an intimidation factor rather than an academic one. Proverbs 18:17 says this. It says, the first one to plead his cause seems right, till his neighbor comes and examines him. And we've all been in those situations before where you hear something that sounds pretty good. It's like, I can't argue with that. Sounds pretty solid. Then someone else comes along and says, well, wait a minute. Did you know about this? Or what about that? What about that? And you're like, oh, hey, I didn't know about that. Yeah, you know what? That doesn't sound so good anymore. I think it's the same thing with evolution. In fact, I facetiously say that evolution 1:1 says that the only one to plead his cause seems right because no one else is allowed to challenge him or present other views. It's the only thing we're presenting in the school system. They're only hearing one view. So, of course, they're most likely going to believe it, or at least portions of it. They're only hearing one shot about it. Now, in one of my other talks, I give the big picture, talking about a number of areas that lead up to what we're going to talk about today. We don't have time for all the details, but when you look at the big picture, whatever your worldview might be, you have to account for the origin of stuff, matter and energy. Where did all this stuff come from? How did you get something from nothing? That's a huge problem for an atheistic worldview, an evolutionary worldview. How do you get something out of nothing? We're skipping that for now. Once you got stuff, how did that stuff form an orderly universe? You know, the stars, planets, galaxies, and all those things. The laws of physics dictate against that. It's just not going to happen, but that's part of the worldview. Once you get stuff, then it's got to form the universe and all the elements in it. Now, once you have planets and things like that, how do you get chemicals on the planet? And then how do you get chemicals to come together to form a living cell? It's one of the biggest problems that an evolutionist has, especially an atheist. How do you get it to become living that could reproduce itself and then change over time? We're not going to spend too much time really on this. Again, one of my other talks, and some of the other speakers will talk about this a little bit. And tomorrow morning when I give my last talk, I'll talk about this very briefly. The last thing is, once you get a living cell, how do you get it to change into every other life form on this planet? This is what we're going to focus on in this particular talk, the origin of the species or the variety of life. How do you get that single-celled organism to turn into a human being? Very interesting. Now, there's a lot of arranging and storytelling that goes on with evolution. For example, we've got 4 modes of transportation up here. We could arrange these things from simpler to more complex and talk about the evolution of the motorcycle, how the small wheels on the back of the tricycle moved into a larger wheel, that rear wheel of the bicycle, and then the chains and gears on the bicycle moved into an electric motor of the scooter. And then the electric motor of the scooter moved forward and turned into a gas combustion engine, and that's how we got motorcycles. Now, everyone knows this is a pretty silly story. Obviously, it couldn't have happened that way, and it didn't. But all I did was I arranged things from simpler to more complex and then told a nice story of how these changes occurred. Well, it's very similar to what happens when teaching evolution. For example, we have the evolution of the horse from Eohippus all the way to the modern horse. So you take some fossils and bones and line them up, and then you tell this nice story. Well, here's an interesting quote from Niles Eldredge. He's a former curator at the American Museum of Natural History, a very ardent, strong evolutionist. This is what he said. He said, I admit that an awful lot has gotten into the textbooks as though it were true. For instance, most famous example still on exhibit in the American Museum, that's his museum, is the exhibit on horse evolution. That has been presented as literal truth in textbook after textbook. Now I think that that is lamentable, but by the time it filters down to the textbooks, we got a problem. So apparently it's okay to be in the museum to show to millions of people coming through, but if you put it in the textbook and teach it as literal truth when you know it didn't happen, maybe that's not so good anymore. Very interesting admission from an evolutionist himself. And here's another example of how fish evolved into amphibians over millions and millions of years. Well, what did it look like in the middle? These transitional forms that are largely, missing. How did it survive? What did it look like in the middle? That's a problem for evolution. But not anymore because they've discovered Tiktaalik. This fossil that's in between, this is evidence of how it evolved from a fish into amphibian. Now, there are actually a number of reasons why this is disqualified. It doesn't count. I'm not going to go into those details right now, but they'll occasionally find some bones and stick it in somewhere in the line and say, we have proof now. This one's already pretty much been disqualified. But doing this isn't much different than doing this, where you talk about how an Etch-a-Sketch evolved into an iPad. These two objects are not that different on the outside, right? There's similarities, and you can picture maybe the buttons changing. What would it look like in the middle? Maybe something like this on its way to becoming an iPad. Well, there's no way that the simple internal workings of an Etch-a-Sketch are going to change by accident into the complexities internally of an iPad. It's just not going to happen. But again, that's what they want you to believe with evolution. It just somehow did happen over these millions and millions of years. So how do we get that single-celled organism to turn all the way into a human being? Well, when we have children, our kids don't come out looking exactly like us. Kind of funny here, but there are changes. Changes do occur. Our kids might have similar hair color, eye colors, and things like that. There are similarities. They don't look exactly like us. Change does happen. Okay, what are these changes? Well, there's basically two types of changes we see. We've got built-in variation, and we've got random mutations. Now, the built-in variation has to do with our genes. We've been talking about the genes and portions on our DNA. It's somewhat predictable because we know that this could code for this option or that option or maybe this other one. We somewhat can predict what might happen. But with random mutations are basically copying errors in the DNA. There are actually some mutations that aren't necessarily random. They seem to be pre-programmed to adjust to environment, but most of them are random copying errors. So obviously you don't know what to predict there because they're random. So we're going to look at these two things in each turn here. We're going to first look at the built-in variation in genes. We have two dogs up here that have medium-length fur. And they have genes to produce this fur. They actually have, two copies of each gene. In these dogs, each dog has a gene to make long fur and a gene to make short fur. In these cases, the genes have combined to give them medium-length fur. When they breed, they will literally copy the genes and pass it on to their offspring, onto the puppies. They will pass one gene or the other. They don't get to pick and choose, just one goes or the other. If they both pass on a gene for short fur, the puppies will come out with short fur. It doesn't matter which gene is expressed in the puppy. They both do short fur. Even if they combine somehow, it's going to have short fur. If they both pass on a gene to make long fur, the puppies come out with long fur. It doesn't have a choice. If one passes on a gene for long fur and the other for short fur, they will typically come out with medium-length fur. It could be either long or short, but it will typically maybe be medium-length fur. So these genes can make a variety of fur length. But genes don't just make fur length. They do other things too, like making big dogs, small dogs, long ears, short ears. The different features we see on dogs all coded there in the genes. We kind of know how that works. Well, you can ask yourself, well, these creatures up here, set A and B, which set of animals seems more similar to each other? Pretty obvious. Animals in set A look a lot more like each other than the animals in set B. Why is that? It's because these animals here in set A are largely the same kind of animal. The Bible says in Genesis that God created creatures to reproduce after their kind. It says that over and over and over. Today, dogs, dingoes, coyotes, and wolves can all breed together. When you breed a dog and a wolf, you get a wolf dog. It's no surprise. This is real science. We do this all the time. It's not a surprise because they're the same general kind of animal. Yeah, we can get a nice variety, but it's within limits. It's within the general kinds. What you can't do is breed a wolf and a dog and get an ostrich. Why? Because they're not the same kind of animal. The dog and the wolf don't have genes to make feathers and beaks. So it can't happen. Well, there's some other animals you can breed. You can breed a zebra and a donkey, and you get a zonkey. It sounds humorous, but it's real science. Why? Are these completely different animals? No, it's basically the same animal. One just has a nice paint job. You can also breed a lion and a tiger, and you get a liger. Why? Because they're both large cats. They're the same kind of animal. Not a surprise, but again, what you can't do is breed a lion and a kangaroo to get a liangaroo. That one's not going to happen because they're not the same kind of animal. There are a bunch of other creatures you're also not going to get. It's these up here. These are kind of interesting. They're fun to look at. This is what happens when you have Photoshop and too much time on your hands, of which I have neither. I got these off the internet. They're very fun, but they're fun because you know how impossible they are. It just can't happen because of the genetics. They're not the same general kind of animal, so we don't expect to see these, but they're kind of fun. So that was a built-in variation, very briefly. Now we're going to look at the random mutations here. Now we're going to switch gears here for a second, and we are now in a state university or a public high school, and I'm going to be teaching you how evolution works. So I'm a teacher, a professor of evolution, and I'm going to teach you how we know evolution is true. I'm going to teach you very simply how it works. We have an organism up there that's going to reproduce itself. It has DNA, so it's got to copy the DNA and pass it on to its offspring. So it does that, and it makes more of itself. It has children, and the children come out looking pretty much like the parents, maybe slight variations, but pretty much like the parents because it's the same DNA. Then the children reproduce, and they have grandchildren, ultimately here, and grandchildren look much like the parents and the grandparents because, just copying the DNA, so very similar. Then the grandchildren reproduce, and, oops, we got some mutations going on here. I'm keeping this very simple. There's always mutations, but we got some significant mutations going on here with some significant changes. You can see some of them. The one on the left there is bad, and then the one on the right seems to be maybe okay. Then natural selection comes along and weeds out all the bad ones. Just keeps the good ones. And then reproduction continues, and the new ones reproduce. We got more new ones, and then we have more of the original ones. And this goes on for millions and millions of years. Can you imagine the great variety we would have with this process going on for millions and millions of years? I guarantee you the non-Christian students in the classroom look at this and they say, can't argue with that, it's very straightforward. But I guarantee you the Christian students in the classroom say the same thing. Makes sense to me, you can't argue with that. But what's really interesting is, many of you are old enough to remember Paul Harvey, who died not too long ago. He was famous for telling us the rest of the story. And that's what we're going to see with the rest of this talk, the rest of the story about mutations. And take a closer look at it and see, what do mutations really do? Can they produce the results that they tell us that it can produce? So I'm going to make three major points about mutations. First of all, that they are purposeless, undirected, and random. Secondly, that they occur in the DNA. And thirdly, that they're almost entirely detrimental or bad. We'll look at each one of these in turn very briefly here. Start looking at the fact that they're basically purposeless. They're not really trying to do anything. Here's a quote from Nova Online, an evolutionary source, talking about mutations. It said, it's sometimes convenient when trying to make sense of evolution to think of changes within a species of having a purpose, as though Mother Nature has some intended goal that she sets out to achieve. The bacteria want to survive, some might reason, when thinking about the declining effects of antibiotics. And so they evolve into resistant strains. Of course, there is no purpose in evolution, just random mutations within DNA, most of which are detrimental to the survivability of the organism. Those are the 3 points that I just made in this quote. It's kind of neat because I made the PowerPoint slide first, and I found this quote later. It's like, hey, that's saying exactly the points that I'm making here. They're not trying to do anything. But often in the literature, you see just the opposite. Here's Discovery News talking about dinosaurs. It said presumably the sauropods evolved large body size as a strategy to deter predators. What are they saying here? In essence, this is the story they're telling. Apparently, according to them, millions of years ago, dinosaurs were not as big as they eventually came to be. And they're sitting around the campfire one night talking, and they're thinking, hey guys, things are not going well for us. Well, we're going to be hunted to extinction here very quickly unless we come up with some strategy. You guys have any ideas? And they said, no, our brains are too small. And then one of them says, well, I got an idea. What if we get machine guns out and we shoot our predators? The first dinosaur says, we can't do that. They haven't been invented yet. It's like, okay, good point. Then another one says, I know, what if we hop on our motorcycles, our Harleys, and we ride off into the sunset? And we can't do that either because they haven't been invented yet. Okay, good point. I know, what if we evolve really large body size? And then the first dinosaur says, now that's a good idea. Are we all in agreement? Yep, okay, break. And they go off and they get big. Is that how it works? I don't know a scientist yet who believes that. In fact, most evolutionists, all evolutionists that I've talked with, they know it doesn't work that way. They said, no, evolution doesn't try to do anything. It's just these random changes, most of which are bad, some are good, and the good ones are preserved and all that. So it's not like you have some creature that's trying to, it needs this, so it's just let's try to get that. But yet, that's how it's conveyed in the popular literature and even in the school systems, that this creature was running out of food in the oceans, and so it needed to kind of be able to crawl up on the land to find more food, so it evolved lungs and all this kind of stuff. And like, oh, that makes sense. Couldn't find food, so it needed to do this. But that's not how it works in the real world. But you read the literature, and too often today we're teaching kids what to think rather than how to think. So they just buy it. Okay, that makes sense to me, rather than like, wait a minute, how did it just all of a sudden grow these legs or learn how to breathe air just because it thought it needed it? It doesn't work that way. So that was the first point. The second one, very briefly, is that these mutations, these changes are occurring in the DNA. So look very briefly at DNA itself. DNA is like a very, very, very complex blueprint with lots and lots and lots and lots and lots of information on it. Here's an analogy. Let's say you had a teaspoon amount of DNA, and you wanted to back up that much information onto CDs. And we back up our hard drives in case they crash. So let's say you had an amount of information equal to a teaspoon amount of DNA. And you're going to back it up onto CDs. Now, a single CD can hold about 100,000 pages of text, just simple text, no graphics. Simple text, 100,000 pages of text on a single CD. That's a lot of information. So how many CDs would you need to back up just a teaspoon amount of DNA? You would need 100 CDs, but don't write that down because I just lied. You would need 1,000 CDs, but you probably guessed don't write that down because I lied again. You would need 1 million CDs, but don't write that down quite yet. That was the last time I'm going to lie. You would actually need 1 million CDs given to you every minute for 9.5 years. Then you would have enough storage space to back up the amount of information you could fit in a teaspoon amount of DNA. It's just amazing. That's 5 trillion CDs. It gives you an appreciation for our national debt. It's just amazing. Picture someone walking up to you saying, I heard you're going to back up this teaspoon amount of information that can be held in that amount of space. So here's 1 million CDs. Not that they could carry it, but they hand it to you, and you're like, oh, my word. They say, I'll be back. Come back a minute later. They give you another handful. Now you got 2 stacks of 1 million CDs. Come back a minute later, give you another stack. They do that for 9.5 years. Can you imagine how annoying that would be? But what we teach, this is just an accident. It just happened by accident. Wow, really, I don't have that much faith to believe that. In the DNA, we know a little coiled-up ladder, little rungs on it. It's like a set of encyclopedias. And the rungs on the ladder would be representative of the letters in the set of encyclopedias. So a rung on there is like a letter out of that set of encyclopedias. And when you put a bunch of rungs together, these nucleotides, groupings of them, those would be the words in the encyclopedia. Then when you talk about genes, that's thousands or tens of thousands of these nucleotides or rungs. That's what we call chapters. And then the volume, like a single volume of the set of encyclopedias, is what we call a chromosome. And then when you're looking at the entire set of encyclopedias, that's what we call the genome. Or for people, it's the human genome. So most of you probably already knew this. It's just a little biology 101. The last section, and this is where it gets most interesting, is that most of these changes, these mutations, are detrimental or bad. And this is where we're going to start to get into some cutting-edge stuff. Everything up till now has been very basic, known for many years. But here's how the story of evolution works. And I got this analogy out of Dr. John Sanford's book, Genetic Entropy, which I think Kevin Anderson has on his table. I don't know if Jerry does or not, but it's a great book talking about the degradation of our genome over time. And in it, he talks about the fact that a single-cell bacteria is equivalent, in general, to about the amount of information in a biochemistry textbook. There's a lot of information in a biochemistry textbook. That's about how much information is in a single-cell bacteria. There are no simple cells. They're all very complex, but some of them are simpler than others. But that's about how much information is there. But remember, we had to change this cell into a human being. So we can't just copy it perfectly over and over and over. We got to make changes along the way. Well, what are these changes? Well, these changes are the mutations we'll see in just a second. But here's a sample page from this biochemistry textbook. And there's some text there on the right from that page. Again, if we just copied this text over perfectly, over and over and over, 1 million or 1 billion years from now, we just have a lot more of these textbooks. So we can't just copy it. We have to make changes. Again, those changes are the mutations. That's the crux of evolution. You make these mutational changes, and then natural selection again says it keeps the good ones or whatever. That's how it's supposed to work. So let's look at what mutations are. Here are some examples. First of all, we have a duplication mutation, where you take a portion and you duplicate it. In this example, the word the, I just duplicated the letter T. So it no longer spells the word the. Now, I know what you're thinking. If you were reading this textbook and you saw that, you'd think, oh, it's just a typo. It's the word the, and you'd move on. It's not how our genes work. If it doesn't spell the, it's not the, and it would move on. Then we have another one here. We have a deletion. We delete the letter E, the first E in energy. It no longer spells energy. And then the last one, a substitution. You take the word electron, you take the N out and put a Y in there. It doesn't spell electron anymore. These are 3 examples of mutations. Now, what's interesting is you could ask a kindergartner, say, what's your favorite book? And then they tell you what the book is and say, if we took your book and just randomly started making these types of changes to it, what would happen to your book? Do you think your book would get better and better and more exciting and new chapters and all that? They will say, well, no, it would get worse and worse. In fact, it wouldn't take very long, and I wouldn't even be able to read it anymore. Literally, a kindergartner will understand this. You have to be highly educated to not get this. And I say that facetiously, but I also want to say that respectfully. The skeptics, the evolutionists, the atheists, it's not that they're not smart enough. They are plenty smart. Most of them are much smarter than I am. This is a spiritual issue. They just don't see it. It has to do with Romans chapter 1. I referred to that yesterday in my concurrent talk. It's a spiritual issue. It's not that they're not smart enough. It's not that if we just give them some more information, they'll say, oh, I didn't know that. Can I come to church and worship Jesus with you now? It's not a lack of information. It's a spiritual issue. We need to keep that in mind as we share this type of information. Very easy to understand this, though. But the challenge for evolution gets worse than that. Just the fact that there are mutations going on. And this is, again, where it gets into some cutting-edge information, which I just think is just phenomenal. Let's say you're looking at a segment of your DNA, and you're reading it. And you're looking at the segment, and it spells out, was it a rat I saw? Kind of a strange phrase, but you'll see why in a second. We're going to clean this up, take the punctuation away, and just write it across the screen, was it a rat I saw? Well, in English, we read from left to right. But you may have noticed already, you can read this backwards, from right to left. Was it a rat I saw? Called a palindrome. You can read it forwards and backwards. Kind of fun. This is what we've been discovering about our DNA. Much of our DNA can be read not only forwards, but also backwards. But the challenge for evolution gets worse than that. Because that was the same message, forwards and backwards. Take a look at this. The word desserts. Oh, sure, no problem. The word desserts. You read it forwards, it spells desserts. You flip this around, and it spells stressed, which is what I get when I don't get desserts. Now, let's introduce a random mutation to this segment here. We'll just randomly delete the letter T. It no longer spells desserts, but you know what? It also doesn't spell stressed. One random mutation not only messed up the message going forwards, but it messed up the message going backwards as well. But this is not really exactly what we see in our DNA. We don't see just little words that flip back and forth. We see up to entire chapters of information that can be read both forwards and backwards. Now, here's a simple analogy to help you understand what we're talking about here. Let's say that you have a job, you work in a smartphone factory, and it's your job to help write the instruction manual to give to the manufacturing plant to make these phones. So your boss comes into you one day and says, hey, I got a project for you. I need you to write the chapter in the manual that explains how the phone is going to download apps from the web. You say, yeah, I can do that. That's what I do. It's my training. You say, okay, great. Then he walks away. He turns around and goes, oh, wait a minute. I forgot about one little detail. when you write this chapter that explains how to download apps from the web, you got to write it in such a way that if we read your chapter backwards, it'll explain how the phone's going to play MP3 or music files. And you're like, well, you're kidding, all right? He says, no, I'm sorry, we only have so much room in the manual, and you got to be able to do that. That's impossible. That's humanly impossible. You cannot do that. You can't even program a computer to do that. I did computer programming for 18 years before I went into speaking, and asked Gary, he would know too. You just can't do it, but yet that's what we're seeing in our DNA. Entire chapters, you read it one way, entire set of complex instructions to make certain proteins. You read it the other way, you're making completely different proteins that have a completely different instructions, system, and function. Yet we're supposed to make random changes. When we do that, we're not only destroying one set of instructions, we're messing with the other set of instructions. But the challenge to evolution gets even worse than that. Take a look at this phrase. I like chocolate later that evening. Kind of weird. Why? Because it's two phrases that overlap. I like chocolate, which is true, and later that evening. They overlap there in the middle, 4 letters, L-A-T-E. This is what we're seeing in our DNA. We see instructions that actually overlap each other. Now let's make a random mutation here. Let's just randomly substitute, take the E out, put an H in there instead. We just destroyed both phrases. It no longer spells I like chocolate or later that evening. One simple change destroyed 2 sets of instructions here. But we don't see just a few letters that overlap. We see up to entire chapters of information that actually overlap each other. But guess what? The challenge for evolution gets even worse than that. Here's that phrase again, I like chocolate later that evening. Let's just take a few segments of it and then bring it down below. And it spells, I like her hat. This is called alternative splicing. This is what we're seeing in our DNA. You can splice out different segments from different genes here and there, put them together, and you got another set of information. Let's introduce another random mutation here. We'll just randomly delete the H there, so it no longer spells I like chocolate, but it also doesn't spell I like her hat. It messed up the spliced information. So again, one change is messing up multiple things. Forward message, backwards message, the overlapping message, the normal messages, all those things. One random change. And what we see in real life is not just a few splice things, but up to long sentences and entire paragraphs that can get chopped out. Go to that biochemistry textbook and just take sentences out here and there, paragraphs out there, put them together, and you got a whole other set of information new in the book. This is absolutely amazing. But the challenge for evolution gets even worse than that. We have embedded information. You take a look at this sentence. Can you show Mike Olson checks from Oliver's labeled facts and set it on Herb's desk? Okay, let's circle every 9th letter in here, and then we'll bring that below, and it spells chocolate. It's kind of a theme going on here. It's my talk. Let's make a random mutation here. We'll just randomly delete the W up there. What that would do is that would take all the letters after that, and it would shift them over one spot. So then all the 9th letters, if we circle those, it would be those letters and bring them down below. It doesn't spell anything. Doesn't mean anything. This is what we're seeing in our DNA. We have embedded information. Random changes are going to mess all that up. But it gets worse than that. We have encrypted information in our DNA. I had 2 interviews with the CIA a number of years ago to work in their cryptographic analysis division. Story for some other time. But let's take a look at this. Let's say you had this phrase up here, which seems completely meaningless to us. But what if you found out there was an encryption key? Meaning everywhere you see an H, it's really an A. Everywhere you see a B, it's really a C, and so on. In fact, everywhere you see a Y, it's really a T. So the one Y up here, that's really a T, and then there's another Y up here, that's really a T. You make these substitutions, and it spells this as an encrypted message. This is what we're seeing in our DNA, encrypted messages. Now let's take a second to talk about what would it take to come up with an encrypted message system. Well, there are a number of steps required. Number one, you have to develop a language system using symbols. So for instance, let's say we have 3 sticks like this, 3 lines. You put them together this way and you say, that's going to be an A. And then when you have these 3 shapes, you say, we put them together this way, that's going to be a B. Keeping in mind, you just have particles smashing into each other, and hey, they come up with an entire alphabet by random processes of nature. Secondly, you have to be able to create and define words. When we put these 4 letters together, it's going to represent that object there. You have to actually create an entire dictionary of words and definitions by particles smashing together randomly. After that, you have to be able to write meaningful sentences and paragraphs, which requires rules of grammar. How do you get particles smashing together creating rules of grammar? After that, you have to be able to establish the encryption system key with the key there. After that, you have to be able to create the system to do the coding and the decoding. And then lastly, you have to be able to develop the ability to read and carry out these instructions. If you can't, the whole thing is meaningless. How do random actions of nature create this system? I don't know a scientist on the planet who can even begin to tell you how this happened by accident over time. And how does it function in the meanwhile while the whole system isn't there yet? But that's what we see in our DNA. Guess what? The challenge gets even worse than that. We have 3D information. This is a little bit harder to depict visually, but you know the DNA, the little ladder there that's twisted up, it makes proteins. And the proteins aren't these straight strings. The proteins get folded very specifically like a lock and key mechanism to carry out their function. If they don't get folded right, they'll probably be disassembled and their components will be reused again. So it's a 3D structure. And Kevin Anderson referred to that yesterday, talking about these things being folded over to be kind of these kissing things and all that stuff. The folded structure is very important. So, visually, let's just say we had 7 words going across the screen there in a straight line, but proteins aren't straight that way. So let's, in a sense, fold these letters and words here. Let's stack them in this format here. And what you see is vertically going up and down, you see the word success. So when you fold these words just right, you get another piece of information there, the word success. So if you don't fold this right, or if you change the letters or delete things and add them and all that, you're going to be destroying the 3D information here as well. So you're messing up with all these other levels, but now you're also messing things up on a 3D level as well. Now guess what? It gets even worse than that. I think this is the last one here, and I'm actually skipping things. We have actually communication from the cell membrane to the nucleus. Information being communicated back and forth. We used to kind of naively think that all the information's in the DNA, in the nucleus, and that was it. Now we're realizing there's actually information outside that communicates back and forth. And we get into the epigenome, epigenetics, which I won't go into here, but it's just so much more complex than we dreamed of, and I'm sure even that's probably nothing compared to what we'll learn next year and all. It's exploding. It's hard to put talks together on this, because by the time you get the PowerPoint together, they're learning new stuff, but they don't quite have a handle on that, and then when you jump over to describe that, then they're on to something new. It just keeps getting more and more complex. But there's communication going on back and forth here. So if you make random changes to the information in the nucleus, how's the cell membrane going to know about that? The nucleus would have to say, hey, membrane, just so you know, we've made these random changes here, so keep that in mind when you're communicating with us. How's that going to be coordinated by accident? But even with all of that, and I'm probably going to skip most of this because Kevin Anderson covered this in a lot more detail yesterday, which I was glad because I don't have time for the details. Even with that, we still have proof of evolution, and that's what Kevin referred to yesterday, that we are 98% similar to chimps in our DNA. Again, most of you were, how many of you were not here yesterday? Just a few of you. I'll just briefly touch on this. Kevin did a great job explaining this. They say we're 98% similar in our DNA to chimpanzees, which sounds like one of those things. You can't argue with that. There's proof. You just can't argue with it. PBS, the public broadcasting system, had a special where they said the differences between apes and humans amounts to just a couple of spelling errors. What do they mean by that? They meant by, well, you just take a creature that's kind of like a chimpanzee, you make just a couple spelling errors, a couple of these random changes we've been talking about, just a couple of them, and voila, you got a human being. That's crazy. There's no way. Now, we're actually nowhere near 98% similar, as Kevin pointed out yesterday. The numbers that I've seen go down to maybe even 70%, 70, 75, or whatever, which is actually what evolutionists expects us to be between us and a chicken. Now we're only that level similar to a chimpanzee. It doesn't make sense to them. It's not consistent at all, but you can cherry pick things and just publish what you want and make it sound like your case is very strong. But even if we are 98% similar to a chimpanzee in our DNA, which we're not. Even if we are, even if you're not smarter than a 5th grader, you can figure out that we're 2% different. If we're 98% similar, that means we're 2% different. Or 98% similar, yeah, we're 2% different. Now with that, just a few numbers here very quickly. The human genome, in the cell of each human, there's about an equivalent about 3 billion letters inside each cell. 3 billion letters with that, 2% different. 2% of the 3 billion letters, which is 60 million letters here. If we're 2% different, that's 60 million differences, 60 million spelling errors. Supposedly, 60 million letters, if you write that out, that's 5,200-page books of information. Okay, too many numbers here. What are we talking about? What they're saying is you take an ape-like creature, you take its genome, and you introduce 60 million random changes. Opening that book and just making these changes, deleting letters, duplicating them, all that. 60 million times, and that's supposed to produce an equivalent of 50 new 200-page books, brand new information, all working together beautifully to create a human being. Is that going to happen? These changes are detrimental. How do you make that many changes and it just gets better and better and better? It doesn't make any sense at all. And others have humorously pointed out that we actually share about 50% of our genes with bananas, but that doesn't make us half bananas, but maybe it does. There's a lot more to it than just genetic similarity, and we'll probably cover that in some of the other talks here. But getting back to the premise of this talk, certain things from a certain distance or an angle look very good, like the BMW here. But again, when we've opened the hood, we didn't see a beautiful engine. We found out with evolution, the engine is missing. There's nothing to drive the story of changing a single cell into a human being. It's just the opposite. It's going to continue to go downhill. Quote from a geneticist here. It says, genetics has no proofs for evolution. It has trouble explaining it. The closer one looks at the evidence for evolution, the less one finds of substance. In fact, the theory keeps on postulating evidence and failing to find it, moves on to other postulates. Fossil missing links, natural selection of improved forms, positive mutations, etc. This is not science. And with Scripture, in the beginning, God created the heavens and the earth. And even though the Bible is God's first shot at writing a book, I think he did a pretty good job. And you can trust it from cover to cover. And we need to. And we're seeing at this conference that true science always backs up what we're seeing in God's Word. And it makes sense. And it just should be very encouraging. So I hope that what you're seeing here was very encouraging to you as we went through just a little portion here talking about mutations and the DNA. And I'm looking forward to hearing the other talks today and tomorrow as well. I like learning and hearing from other speakers. But I think this is so cool how cutting-edge science, we never have to be afraid of it. Even if temporarily they come out with something that says, this doesn't look so good for the Bible, we just have to wait for them to evaluate it more and realize, no, we were wrong. Like the junk DNA we heard about yesterday, or the similarity between apes and humans in our DNA. The more work they do on it, the more they realize, okay, that doesn't count anymore. What typically happens, my experience has been, they'll come out with something that says this is like proof of evolution. It's so strong you can't deny it. And what typically happens is a limited number of scientists discover something, and they come out with the bold claims. And then shortly after that, more scientists, many evolutionists, look at it and they say, what are you guys talking about? This is not what you said it was. And then some of that will creep into the literature, and eventually they let the information out, and even creations can look at it and see it for themselves, and you realize, yeah, you guys were way off on this, and then we finally get to hear about it. But it usually sticks around for a while in the common literature, in the textbooks, even though they know it's not true. The peppered moth and things like that, they hang around for a long time until another exciting discovery comes out, and they'll say, okay, yeah, you guys were right about that DNA or peppered moth or whatever, that's not really right, but that doesn't matter because we got this now. This is really exciting. This is proven. We didn't have it before, but we certainly have it now. And then that goes through the same cycle. Very quickly, we realize, oh, it's not what they really said it was. The discovery of the gravity waves that was, a month or so ago, proof of the Big Bang and all that. That starts to fall by the wayside, but they don't admit it until they got another one to switch your focus to. And that's just going to happen over and over and over. So they will always have exciting evidence for evolution. Just have to give it some time before we realize why that doesn't really count, but then expect that they're going to come up with something else as well. So with that, before we go into break, I wanted to explain the little handout I gave. It's just a sign-up for a free email newsletter that we have. I send it out once a month, and in it I just talk about, answer some top 10 questions. Each month I pick a different question to address. Responses to news stories like the gravity waves that came out, I addressed that in an article. And then you'll see my speaking schedule when we have new resources coming out. The talk that I gave yesterday, Faith is not a four-letter word. We're coming out with that hopefully by the end of August. Just recorded it in the studio a week ago. And other resources you can be alerted to. So if you're interested, you can just tear it off. You can keep half of that as a bookmark. You can just turn it in at my table out there. And I'm not going to go through all my resources. I'll skip that for now. But we've got just a couple minutes left. We can do a little bit of Q&A. If you ask me any tough questions, I'll probably refer to Jerry or Kevin to answer some of those things. But I'll do the best I can to answer any questions you have. So just ask it loud enough for me to hear. I'll repeat it so everyone else can hear it. And I'll try to be very brief in answering it so we can get to as many as we can in about maybe 8 minutes or so. David.
You've made a convincing case under the scenario of multiple. It would be impossible to make even a single evolutionary takeover mutation. How common is this? Is this phenomenon just the genome, or is this a feature of?
From what the question has to do what we've talked about, all these different things of the forwards and backwards and overlapping and splice and all that, is it prevalent throughout the genome? From the reading that I've done, is at first they discovered a little bit of it, then more, and then they're saying like, wow, this seems to be happening kind of all over the place. There are different percentages that are given as far as how much portion can be read forwards or backwards, how much of it overlaps, how much is spliced out. It's really hard. I mean, I think Kevin referred to it yesterday that we used to simplistically just think you start here and you end there and you're done, like a book. But now because it's spliced, I'm even wondering, how do they even know the information capacity of the DNA anymore when you not only have the straightforward message, but the backwards and the overlapping and the spliced? It theoretically, in a sense, could be almost infinite. So it's hard to really say there's this much information in the DNA because of we just keep learning more and more and more. So, but it just keeps expanding.
The answer is you don't. That's why I don't use the term information, because we don't know how much information is in the DNA.
Sure.
Because every time we estimate it, we're wrong.
Sure. Yeah. And it's what's nice is it's fun to be wrong because we're always wrong in a simplistic way. It's even more complex than we expected. Rather than like we were wrong and I guess the evolutionists were right. It's like no. We weren't quite right, but it's even worse for the evolutionists than they thought to begin with.
So with those different ways to read DNA now, are there mechanisms in the organism that read that, and then that coded information, that spliced information, encrypted information, that is also being expressed in the organism in ways that we don't quite understand at this point? Or?
Sure, with how it's read, and again, I'm totally embarrassed talking about this with having Kevin and Jerry here, so you guys can chime in. But I think one of the complexities, again, I always keep things in a simple way just because I probably don't know enough to wow you anyway. But what's interesting is it's not just that DNA in the nucleus, it just does everything. In fact, when they were talking about the large portion, 98% being junk, now they're realizing it's not only not junk, but it plays a key role in telling the 2% what to do. And so we talk about the epigenetics and all that. There's information outside the genome that's giving it instructions of what to do. In and of itself, it doesn't do as much. It's got to be given instruction. There are histones and different tags and things that will go on and say, okay, I'm going to use you, but not what I just used you for now. I'm going to use you in this way here, combined with this one here. Now I'm going to flip you backwards. We're going to start here and stop there. It's all these instructions telling it how to be used. Well, how did that evolve? When you have a set of information here, but then you have a set outside of that telling it how to be used in multiple ways and splicing and all these things and overlapping messages. It's like unimaginable how that kind of a system could evolve. If we saw that in a computer programming language, we would just say, we would give praise to the programmer, thinking, how in the world did you write programs that could read forwards and backwards and spliced and overlapping and encrypted and all these things? It would just be phenomenal. But we see it in our own DNA, and we think, well, that could just happen by accident. And Carl Sagan, when he was alive, it's kind of interesting, he was always searching for evidence for extraterrestrial life. And someone asked him, well, how are you going to tell if the signals you're receiving from these radio telescopes are coming from intelligent life? He said, well, it's pretty straightforward. If there's any pattern or any complexity to these signals, we'll know that had to come from intelligent life because that wouldn't happen by accident. But he could look at his own DNA, which blows that away, and he was willing to say that could just be an accident. So there's an example of a very intelligent scientist not making any sense at all because it's a spiritual issue. And so, yeah, it's very complex and very, very exciting.
I'm pretty sure there's a passage in the Bible that says specifically that the flesh of human beings is different than the flesh of animals. I don't know if now. I was wondering if there are any Christian geneticists studying it from that approach, how the genome or which genomes in human beings are specifically different than animals. But that's what the Bible.
Yeah, the Bible does teach about the different fleshes, the flesh of man and animals and birds and fish and things like that. And I don't know if Jerry or Kevin want to comment on that. Have detailed studies been done about that type of a verse of the differences between the flesh, in the sense of a fish, and a bird or a human?
I have a passage.
Okay.
Body as body as all flesh is not the same. Man has one kind of flesh, animals have another, birds another, and fish another.
Yeah, it specifically delineates those, and it goes on in 1 Corinthians 15:45, saying that Adam was the first man. And I'm ignorant enough to believe that that means there were no men before Adam, because God is saying Adam was the first man. He's distinct from the rest of creation, made in the image of God. God is not a physical being, so we're not made in his physical image, but we're made in his image as far as his attributes to be able to know good and evil and love and experience him in that way. So it's very interesting. And yeah, the Bible said that in 1 Corinthians, long time ago. They didn't have microscopes and telescopes and all that. So how did they say that? Which today we're realizing, wow, they were actually right about that. In my talk tomorrow morning, I'll be largely talking about the human ear. But before that, I'm going to give some basic stuff and advice on how to witness and how to share your faith in a very simple way. And I'll be talking about some evidences. I'll give one example of evidence for the inspiration of the Bible, in which it's sharing some things from the Old Testament that today we realize is scientifically very accurate. You've got to wonder, how did Moses know to write that? There's no way he could have guessed on that. Well, the evidence is that God obviously inspired him to write that, because he wouldn't have just guessed on that only. Really exciting, but so it does tie into, the Bible makes all these statements, and we do find out today that science is verifying that over and over, that the biblical writers were right because they were inspired.
Yesterday, Dr. Anderson said that we can observe between 75 and 150 mutations from parent to child. How does that relate to what you've been saying today? How much is that messing up the ability? My kids right here.
Oh, sure, yeah. I'll comment briefly, and then Kevin can jump in too. With the estimate of 75 to 150 new mutations each generation, like my parents had a bunch of mistakes in their DNA. When they had me, they added another, let's say, 100, 150. And then I took their mistakes plus the new ones, and I added another 100, 150 to my kids, and yeah, we are going downhill. So there's two things. One is it's going downhill at a certain rate where you can trace it back to see about when might it have started, which gives you a biblical time frame, not an evolutionary time frame. It also tells you about how long can we last. We can't last another, a million years or whatever. But it's also interesting that God has designed our DNA to withstand a fair amount of changes and accidents, and we can still function. I think Kevin mentioned yesterday, and there's another quote about, one scientist said it's amazing that we're not dead 100 times over. If we've been evolving for 6 million years, these mutations are accumulated, we shouldn't even be able to function. And, talking about computer programming code, I don't know of any code in all the years that I did programming where you can make random changes and have it still function. Now, you could take Microsoft Office and make a random change, and maybe one of the drop-down menus in Microsoft Paint would be missing an option. Well, you can still use the program, you're okay, but you're missing one little obscure thing. And you can make a few of those changes, but it won't take long, and it won't even boot up. You can't even get Microsoft Office open if you make too many changes. So it's amazing that God allows these mutations to occur, but yet we can still function for the most part. I don't know how you do programming code like that, but God figured it out so it could withstand changes, and not everything is detrimental. Very few mutations are lethal to the organism. Most of them are only slightly detrimental, which is interesting. Evolutionists say, well, yeah, okay, we know most of them are bad, but they're only slightly bad, so it's not a problem. That's a huge problem for them, because they're only slightly bad, natural selection doesn't even know they're going on there. They get passed on to the offspring, and they accumulate. It's like rust spots on the car. I think it was John Sanford's example in his book. You get a brand new car. What if you got one rust spot on the bottom of the car? You wouldn't even know it's there. Then you get another rust spot somewhere else. You don't even know it's there. There's just one atom changing into iron or whatever. And it just slowly happens, but eventually they accumulate and this car starts falling apart. It's the same thing with our genetics. Yeah, there are small changes and they're only slightly detrimental, but they have an accumulative effect. Eventually, we shouldn't even be able to function anymore. It's okay on a short period of 6,000-year history and flood about 4,500 years ago, but it doesn't make any sense if you bring in an evolutionary scenario with that at all. So it looks like we're about out of time here. I appreciate you putting up with me talking a million miles an hour. I'll be back again tomorrow morning with another talk, and I'll be at my table during the break. Let me just close in a word of prayer. Dear Heavenly Father, we just thank you for this time we've had to look into our DNA, and we just thank you for the brilliant minds and the scientists that we have who have done this cutting-edge research, and just thank you for allowing me to be the middleman here today. And I pray, though, for each person here in this room that it's not about amassing a bunch of facts to win arguments, but it's about strengthening their faith so that they're ultimately better positioned to share the gospel message with a lost and dying world. And we just thank you for the graciousness and patience you show us each day. We pray all these things in Jesus' name. Amen.